Good
Okay.
afternoon, good morning, and good evening.
Yes. Hi, everyone. I am Mirko Baggio, Director of Business Development for Zappi Group. I'd like to welcome you to this session. Please remember that this session is also being recorded and will be available to watch on demand following this session. If you have any questions during the session, please add them on the Q&A, and you can find the tab on the right of your screen. Note that your suggestions will be sent privately. With that, I would like to introduce our speaker. I'd like to introduce Julian Seume, Chief Sales and Marketing Officer at Wiferion, who will be speaking today about wireless power in large AGV and AMR installations. Wiferion is working in the same environment and market as Zappi Group. For this reason, we have many common projects. So welcome, Julian. Please take it away.
Thank you, Mirko, and welcome everyone. I hope you can clear me here and see me. I'm very honored and happy to be part of this. So first of all, thank you, Zappi Group, for this great opportunity to share new technologies and ideas for our industry with you and your audience. And Mirko, personally, thank you very much for the support over the last years. And yeah, we're happy to be here. My name is Julian. That's totally fine. Let's keep it easy. I'm the head of and marketing as well as the CSO for Wiferion. Wiferion is a former startup. Now we call us scale up, as we are really growing fast into the industry of wireless charging. And our main industry is definitely AGV and AMRs. And hopefully I can share something today that brings you new ideas for common projects or ideas. So I titled the presentation Unplug and Play. Is wireless power a game changer for large AGVs and AMR installations? And before I start, I would like to show you a picture of the vision of Wiferion. So what you can see is basically a warehouse or a production site with many blue tiles and charging installations. But you can also see the same installations on different kind of vehicles. And yeah, let's see if the vision is possible to fulfill and what it's need in the future to make this happen. So the first question in the round, and I'm not sure if you're able to answer, but I would like you to ask yourself, what's your style? And in your style, I mean, how are you using power in your daily device, your smartphone? Are you still plugging in, or are you using already contactless magnetic inductive charging on your phone? I'm not sure if we have a poll here, but let's say my personal opinion is that since I use a wireless charger, I don't forget to plug in my phone overnight next to my bed, which gives us or gave us a lot of, especially me and my wife, a lot of headaches in the future when in the morning the phone was off. So for me, let's now transport this, why this question is interesting for our world where we're living on. I don't know if every one of you is in contact with robots or AMRs, but that's what we see. We definitely see a certain revolution in the world of warehousing, production, service robots. There's so many applications that's going to get automated and automized compared to many years ago. And it's clear one thing, all of those robots, they have one in common, and that means they all need power. So they all have the same challenge. How do they get the power quick and robust? So automation is clear, it's coming. We see a lot of industry process being automized. And these production names or these manufacturers are just an example, but these are the most typical applications we actually see, especially in warehousing robots and also in production sites. If you look at the left side, the production robot, that's a clear, very stabilized and established production robot in mainly automotive production or large production plants. Picking like a Locus, Fetch, or Six River Systems, which quite very interesting where this move's going to go. So this is an area very high potential of growth rate, what we see in the robotic of picking. Warehousing, line feeding and production side, or of course, goods to person. So many applications are coming where we prevent the future, basically people walking to a location, but the goods are coming. So we see it through the whole world. And I try to understand a little bit, what does this all have in common? What does automation mean? And yeah, I wanted to be, let's say, not totally creative, but I looked up in a Cambridge, very old school dictionary. And for Cambridge, automation is defined as to make a process operated by machines or computers in order to reduce the amount of work done by humans and the time taken to do the work. So we look into efficiency, getting things faster done and without or with less human interference. And Wikipedia says automation describes a wide range of technologies that reduce human intervention in processes. The benefit of automation includes labor savings and improvements to quality, accuracy, and precision. And of course, this totally is in line what we are all facing. We are all facing labor shortages. We are all facing problems to getting the right persons on the right time. Lean production is not only a wording, it's clear. Everybody needs to produce lean. And one thing is also clear, robots don't get sick. So I tried to find a synonym for this, and I found basically robust as a very good explanation what a robot is. And also, again, I looked it up, and robust is defined at Cambridge strong and unlikely to break or fail. Or the dictionary.com said strong and effective in all or most situations and conditions. So robustness is the property of being strong, healthy in constitution. When it is transposed into a system, it refers to ability of tolerating perturbations that might affect the system's functional body. So those two things, automated and a robust automation, are key for a stable production and warehousing line. Coming up to where is the weakness of those robots? From our point, to function, to communicate, to move, to act, to give us is one of the most critical parts in the robot. The weak point of electrical power devices is not being powered. And we would like to change that. Looking at those upcoming topics I said, is wireless power the game changer for large AGV fleets? I want to give you I looked for it's from a reporting company that does regularly reports on development on markets. In this case, it's the Interact Analysis that basically forecasts the growth rates of installed based AMRs, which are deployed just in order fulfillment. So basically e-commerce and warehousing is rising dramatically in the next 2 or 3 years as well. So this means once you have a not robust system that is not stable, it's not a problem if you have 1, 2, or 3 robots. But once you have 1, 2, 3, 50 sites with each 200 robots, issue because you cannot handle it. And in order to be able to manage those huge amounts of transportation and executions of robot activities and tasks, you need to have fleets that are more efficient. And secondly, the robot needs to be 100% reliable. Once again, it's not only a use case that needs a robot. A business case is always the key in order to make a decision to place a robot. Does it really valuable? How's the return on investment? And from our point, the business case of a mobile robot is based on high availability and reliability of robots, meaning you pay for the robots that are working. You don't want to pay for robots that are sitting or not working. And unfortunately, the charging is still most of the time an unproductive idle time of the robot. So let's focus on optimized, efficient working fleets and reduce any kinds of mistakes in terms of wrong navigation, crashes, or problems due to energy supply. The investment in automation and robotics is very huge. So the short return of investment and payoff times are needed to make this decision. Our solution, or at least what I and we believe is one part of the solution, is the high availability of the robots and a reliable fleet. Of course, I need to look what's alternative. And at the moment, autocharge is not 100% defined what's the best solution. What we see is that especially contact charging, which is the main and standardized charging at the moment, is not 100% safe and reliable. We have wear and tear. Of course, due bad positioning, arcing, or bad contacting can happen. And of course, in a surrounding where workers are carrying material and driving around on forklifts, tripping hazards or other topics like broken contacts are unfortunately still a topic. Let's have a quick look at what Wiferion does and what's the big difference. We do wireless mobile energy systems. So we charge with a magnetic field without a contact. It's very simple. It basically has 4 components and a couple of add-ons. So we have a charger on the wall, which is number 1, and we have a charging pad, which can be installed on different locations. There's of course an opposite charging needs to be installed on each of the vehicle with a regulator, which is called mobile electronics on our side. And this basically feeding the energy into a battery system. And we actually add on to our solution a fully charge optimization platform, which is called Energy Hub. And it's guiding an energy management system to it. One very critical topic just to understand, the charger is fully agile, so we can charge any kind of energy sources. It doesn't matter what kind of battery technology it is, what chemistry. We can even charge supercaps. So that's basically as a background to understand. It's a very simple and lean charger. And in order to give you a little bit more of an understanding what kind of applications are there and which companies are already doing this, I brought you a little movie. Hopefully it runs smooth. So very simple and different applications I'm going to show you just to get an understanding. We do an installation very simple just by laying the systems on the ground. Of course, larger fleets can also be arranged together and make it on a smart charging curve in order to optimize energy flows into the factory, for example. It's very simple, lean and clean, flush to the floor to be integrated, and very flexible if you have changes in your factory or warehouse situation. We don't need to go into infrastructure if not needed. Completely new possibilities to install those on the vehicles because there's no physical contact and no pressure allows to install chargers even on side or the top of a vehicle. The system is also very interesting, especially wireless in itself, to charge anywhere outside, as it has a high IP65, 68 rating. This is an example where a manufacturer of cars in Spain actually charges the vehicles outside as they didn't have space in the factories. In order to use very short stopping times. One of the biggest benefits is that the charger only starts when the vehicle is over the charging situation. So there's no opportunity that any kind of energy is directed to a wrong position. A smaller version for low vehicles or side mounting is possible, meaning it's very flexible to integrate in different kind of vehicles. The opportunity to charge at 2 or 3 times the power of a standard system. As there's no contact, there's no wear and tear on the product, and it sends the complete data of the battery system during the charging process to the cloud software and allows optimized charging routes and optimizing fleet management in larger applications like warehouses or production sites. So Wiferion, basically not only us, but wireless charging, safe, simple, and robust. It's a very simple new way to transport energy without contacts. 2 or 3 basically standard informations about installation and how this is deployed. Very simple, as you've seen on the video. There's an opportunity to put it on floor with different maps, or customers are even building their own little ramp for vehicles. But also in-floor is possible with an own capsule system that allows us to implement it into heavy loaded areas with forklifts driving around, same to the chargers being used for AGVs. And of course, vertical or on the top. These are all things that are possible in order to implement the most easiest way, because as there's no contact needed, we don't need to put any pressure on it. These are some examples, and I only want to highlight basically the right solution, which is called flush to the floor electronics and cable protection. It's a WCPS. It's a wireless charging protection system, which we invented together with a partner, Polcon. We basically are able to implement it fully into the ground, the charging, without any loss of efficiency. And just to get a feeling, the efficiency of the wireless charging, which is nowadays available, is fully comparable to a contact charger or a cable charger. So our systems reach up to 93% of efficiency by placing the vehicle on top of the charging pad. Let's look at larger applications, and again, and not only think about why maybe this technology is interesting because I don't have any wear and tear. What can also be done, and that's what I want to basically give into the round, and also hopefully put a spark into ideas of you gentlemen and ladies who are listening and maybe discussing later on. We believe that implementing, and that not only the technology of charging should be wireless, but also that the process of how we are executing basically charging strategies can be completely rethought. Robots and the highest productivity within process charging. So just imagine you never have to think about charging again. We're going to try together with you and your customers to implement the chargers in their daily routine. As they are flushed to the floor and without any harmness or a chance of tripping, implemented in or to the ground, we can place them on the certain locations where the vehicle anyway needs to stop, or where there's a waiting line or as a queue. And those times, normally which are an idle time, where cars are standing, we can use for powering up lithium-ion batteries or any kind of batteries in that vehicle. And that's basically resulting in a completely new way of rethinking to design a process of implementing AGV and AMR fleets. So just look at it. That is a typical logistic loop. You have a certain number of vehicles that are doing their daily processes and their jobs. And there's a certain number of vehicles which are at the moment charging. So they basically have a sleep mode, or they're not doing anything. So they are in sleep, meaning roughly the customer needs a certain amount of vehicles as an add-on. Just imagine the solution. You are able to at least implement, maybe not all of the charges, but a couple of those are implemented during the process, meaning you can actually reduce the number of vehicles of the total in the project, and of course in the sleeping mode. So of course the best result would be to completely skip away additional vehicles, reducing the cost of the project, reducing the cost of the investment on the vehicles, and being more efficient and available with the charging implemented into the process. And now I'm come to one question, which is, I think, very interesting nowadays and discussed, and hopefully that's also one. If you're an expert in AGV and AMRs, you know about software that's talk about interoperability. So everybody talks about it, VDA 5050, one standard for managing and guiding vehicles. I would like to put into your head an option, knowing now that there is systems available that are able to charge any kind of battery, any kind of vehicle, 24, 36, or 48 volt with the same charger. meaning wireless is one solution of interoperability that is not connected to a software. So basically, interoperability are sharing on different locations the same charger. And that's basically what wireless allows. As there's no contact, we just need to have the same chargers on each vehicle. That means also not only saving in terms of vehicle, it also saves if you're able to implement the charging in your process, in your daily business. That frees up very expensive space and room in a production or warehouse site. You will gain additional floor space. So I'm completely finished. I want to give 2 or 3 more add-ons about benefits of wireless charging in general, and that's mainly the case is very robust and you can install it anywhere, especially the Wiferion systems, which have an IP65. As mentioned, it's a one-for-all system. It's really open to charge any kind of vehicle with the same charger. It's a little bit comparable to nowadays e-mobility. It was very long. But most of them can use the same charger. So it's already out there, but it's not executed yet in the world of same as any standard chargers available. We have an omnidirectional approach, meaning you can drive from optimizers again, routes of AGVs. You're very free to use it. The position tolerance is very low. Are needed in order to use very short breaks and to reduce idle times and use any kind of stopping time for additional, let's say, power-ups. The full power of the systems are available in roughly 1 second after the vehicle is closed. Yeah, no wear and tear, no sparks, and no cleaning. Especially in rough environments, wireless charging is a game changer. Software part, which is part of the family now since the Logimat last week in Stuttgart. We actually bring together with our system a charge optimization platform, which gives us more insights of your energy usage, of your situation of the vehicle, of the battery lifetime, in order to optimize vehicle availability, charge optimization, and to minimize downtimes due to any kind of service that might appear on the vehicle or the battery. Last but not least, as I said, Wiferion is a startup. Luckily, we have been very successful over the last 3-4 years. Since 2019, the system is available, so roughly 3.5 years now. Manufacturers, some of them are listed on the left side, and we are very happy to be able to power already and change a lot of intra-logistic and warehouse and production processes over the last couple of years. So that's just a quick overview where Wiferion chargers can be found. And as it said, it should not only be, and I hope that's the case in this presentation, it's not only a production or let's say a product commercial. It should really give new ideas how things are done. I brought a couple of success cases and customer examples that you can get a feeling what's possible and then think about how to move this further, maybe in your area or in your process or in your vehicle. So we started a couple of years ago together with SafeLog to develop the system also being implemented on the ground with those kind of little plastic mats. SafeLog is one of the largest AGV manufacturers in Germany. And they decided after a couple of tests with us that all their vehicles are now being equipped as a standard with wireless charging. They really saw the advantage that the installation for them is very simple, only consisting of 2 components in the vehicle, and they needed to secure the robustness on the charging cycle. So they implemented now for all the vehicles available the Etalink 3000 systems. It's definitely a significant increase in performance, which they achieved, now being able to fully charge during any kind of breaks and optimizing the availability of the vehicle. Another example is also to retrofit existing vehicles. So actually, this is a battery tray solution, where in the former times, the company SMA, which is a mid-sized German company that does solar equipment, they actually had a battery swap as their standard energy supply. So they were driving after each shift, after hours, they were driving to a large room, which took a couple of minutes, and they changed the battery and they moved back to the typical logistic loop, which the P50 Linde every day does. And in order to basically eliminate those expensive and also not 100% safe battery exchanges, we added on wireless charging plates to a new lithium-ion battery, which was basically the last battery change on the P50 we ever done. And now, anytime this kind of vehicle drives the logistic loop, it has certain stopping points. Every time it gets a little bit of additional energy. So we not only reduced the standing times from to zero battery swaps, we also optimized the availability by more than 3 hours additionals for this. Common application, and that guides a little bit to the topic of this presentation, especially on large applications, on large installation and deployments. It is important that you have a robust system, and realized this. Sorry, but carry pick robustness of the charger was, after a couple of months and years, one of the most critical service issues the customer had. So we removed the contact charger and moved into a wireless charging solution for a typical goods-to-person application with many hundreds of AGVs driving around in a dark warehouse. And last but not least, ABB Mobile Robotics, formerly ASTI, as you know, they have in Spain an installation where they had that issue of having not enough space somewhere to install a charger in-house. And as the application is an outside truck, they decided to implement the wireless charger outside the production hall, where the vehicle gets basically loaded with new material, and they used those 15 minutes of loading time for the vehicle in order to charge. So they reduced completely space they had in the past for chargers inside, as well using opportunity or in-process charging very efficiently. But not least, yes, Wiferion's product portfolio. I basically brought this to give you a quick overview. We see us as a wireless charging provider, which also gives, if needed, a modular battery solution together with the energy charger. Again, it's free of choice. We can charge with the charger any kind of technology, any kind of battery. It's just an add-on to the product portfolio. And last but not least, to give you a little bit more, we are based in Germany as the headquarter in a small town called Freiburg in the Black Forest. And we have a subsidiary in North America, which is basically taking care about North American customers or European customers that are basically sending vehicles and product and material to the US or Canada or Mexico. So that's basically what Wiferion is. Maybe 1 or 2 minutes, and then I'm good and happy to discuss with you what you think about wireless charging in general. It's very simple. The system, all the systems are quite similar. We have, which is a charger and a charging pad, and there's mobile components which are basically installed in the vehicle. In this case, it's the newest member to the family. It's the Etalink 1000. It's a system for smaller vehicles, which goes up to 40 amp and is basically installed especially on small applications in sorting or warehousing. The most longest and our first product is the Etalink 3000. That's the one with more than 8,000 systems being sold to the world. It's a 3 kilowatt charger that is able to charge 24, 36 and 48 systems basically on the same charger. Again, 2 pieces go on a stationary side, so in the infrastructure or on the infrastructure, and 2 small pieces, the charging plate as a regulator, which is connected to the battery, goes into the vehicle. So very simple. And the same is the Etalink 12,000. That's the largest brother of the family, which is on the market since roughly a year. We go up to 200 amps at the moment on a 48 volt level. And yeah, I'm very happy to hopefully discuss with you guys. And ladies and gentlemen, if you are interested to talk about how wireless could be a game changer or not, and I'm very open also to discuss further questions you have. So thank you very much.
Thank you, Julian. Thank you for your very interesting presentation. Okay, so maybe we can try to shoot to you some questions from the audience. And the first question says that basically why wireless charging is, let's say, more important for AGV AMR versus traditional vehicle, with operators, I guess. So I think the title of this presentation is for AGV and AMR, but can be used, I guess, is the meaning of the question, for other vehicles, and why probably is more important for AGV AMR.
Yeah, Nico, I'm not sure if I understood 100%, but let me repeat the question, and then hopefully I can answer. So what I understood, why it's more important, the wireless charging, or why we are focusing on AMRs and AGVs and not so much on, let's say, manual vehicles. Yeah. It's quite simple. Of course, it works with manual vehicles as well. And as you've seen in the video, there are installations that are out there. But the core big issue is that AGVs and AMRs are unmanned, meaning they need to work on their own. And let's say, assuming we have large installations, especially looking into the future where black warehouses, so warehouse without lights, completely dark, without any personnel on site. So you need to have a very robust charging on that solution. But I fully agree, wireless charging will be the standard of charging in the future, and not only in our industry for forklifts, AGV, AMRs, smaller vehicles. It will also be the standard for wireless charging in the e-mobility. I'm 100% convinced that's going to happen. I don't know how long it will take, but in the future, once you order your electrical car, you have the options. Do you want a cable charger, or you want a wireless charger, or both for your garage? And you will just get it basically with the car. You place it on the ground. The vehicle will most likely drive alone in the future on top of it, and you never have to worry about putting in a cable, a dirty one, a broken one, forgetting to release the cable before driving. That's definitely coming in the future.
Mm-hmm. Okay, thank you. So we have here another question about the fleet energy management. So you know that when you have many chargers on the same grid, you have problem to manage the power if all of them they are working together. So this kind of activity is implemented by Wiferion, or is in charge of the, let's say, fleet owner or the manager of the site?
Yeah, understand. Very good question. Actually, that's one of the beauty as well. Just imagine the vehicle arrives on the charging pad. It sends the complete data to the stationary component, and the stationary component is using that information before it fully ramps up the charging process. So that's why we say our charger is intelligent, and those charging stations are actually, especially with our software EtherHub, connected to each other, and they're going to do, if the customer wants it, align the power outage and the power usage over, let's say, the whole charging fleet in the warehouse or in the production site, in order to level out the, let's say, grid power needed. And that's, once again, that's one of the biggest advantages to have a smart charger, which needs, of course, lithium-ion batteries on the vehicle side in order to optimize, to understand what kind of charging curve I want to use at the moment, how much do I need in order to optimize my charging strategy for the factory, but also how to optimize the charging strategy for each vehicle and battery life. So that's absolutely possible, and that's one of the key elements why wireless is definitely a a game changer for larger AGVs and AMR fleets.
Okay, so next question. During your presentation, you mentioned about interoperability. That is very important. And you said that it's possible to use different voltage batteries, or let's say installed in different vehicles. And what about the power? So I think that this question is pointing to the fact that you have different power availability of solutions of systems, but maybe on the 12 kilowatt, maybe you can charge a smaller vehicle. Is it possible? I think it's the meaning of the question.
Yeah, I understand. Let's put it this way. The topic of interoperability is of course connected to each of the systems. So meaning a 3 kilowatt system has a 3 kilowatt size, and those sizes need to match. So meaning I can use the 3 kilowatt system on different kind of vehicles, and they all can share the same charger. And the charger will then realize, is it a 24 volt, is it a 34 volt, or a 48 volt battery, and what's the status, and adjust the power on that typical application. I cannot yet, let's say, maybe that's coming in the future, I cannot charge a 1 kilowatt charger on a vehicle with a 12 kilowatt charging system. That would be very dangerous, let's put it this way. And it doesn't work because the magnetic fields are designed for each other. But let's absolutely, I'm on your side. And let's say looking into the future, maybe there's one charger on the ground that is able to power different kind of size vehicles as well. But trust me, a 3 kilowatt system is a decent size that fits in 60, 70, 80% of the nowadays AGV and AMR applications. And just thinking about different manufacturers, an Agilox, a KUKA, a SafeLock, and a Linde are all sharing one charger. That is real interoperability from our point of view already.
Okay. So another question, can the BMS of the battery request a current from the charger, or does the charger only look at the voltage of the battery?
Yeah, good question. Again, both is possible. So we have CAN communication added on the charger. So if the manufacturer of the battery wants us to talk to, or we are able to integrate the protocols, of course, we will adapt to the status of the battery. So it's clear one of the key elements, it's an intelligent charger. So we transport the whole information from the BMS through our systems and can even put it into a larger cloud to optimize it. But also it's possible, for example, in the lead acid where there's no BMS integrated, we define a standard CCCV charging curve, which is basically a standard charger, which is also possible. Of course, we would like to go the whole way, so do it intelligent with a communication, which is we are able to basically set also for each of the battery supplier and the different communication protocols.
Okay, maybe a question pop up now in my mind. And how is the communication between the vehicle, let's say, and
the charging? Huh?
The charger is the cameras, I guess.
It's not. Yeah, I mean it's a CAN bus between the battery and the charger, but between the station and the vehicle, we do an infrared communication. So basically, once the vehicle arrives on the charging plate, before the current and the power and energy is started, we basically ping with infrared communication tools and protocols and send the data as we receive it from the battery to the charger, and then the charger on the wall basically is optimizing or providing the right current and the right voltage and power to that arriving vehicle.
Okay. And maybe I have a question from my side this time, waiting maybe someone else will shoot other questions. So how you see the market, let's say, for this kind of products? Recently, I participated as well to Logimat in Stuttgart, and I saw, let's say, a lot of your systems already in the market, but also competitors. So I guess that the market is moving on in this direction.
To be honest, yeah, we are also very happy to see others doing this, because that would mean, I mean, we had this idea maybe to tell a little bit about Wiferion. We are a startup that was founded from a research institute in 2016. And the four founders, actually, they worked already for more than 5 years on that wireless charging, actually on a project to power basically an e-mobility. At that time, it was a Volkswagen Caddy. On their research time during that ESA time, they powered up a Volkswagen Caddy with 20 kilowatt over 25 centimeters distance with a world record efficiency of 95%. So actually, those guys who invented the product have been with that topic since now more than 15 years. And somehow they realized in 2016, hey, we have this made for the cars, but in 2016, no one was interested in e-mobility, at least not at that stage where we are now. And that means they made the turn quite early to go to a new area or to a new industry where already vehicles are equipped with batteries. And that was the warehousing and production side. So we were, of course, gambling a little bit. Is that a technology that works? Is that technology that's interesting enough? Does it solve issues? And luckily, now it turns out we are not the crazy ones that only does this and we are gone in two years again. It's clearly to see it's a trend that we, hopefully also pushed. And from my and our point of, it's a disrupting technology which will not end at warehousing or robots. It will clearly go to e-mobility as well. Of course, no one else has this amount of experience of 8,000 systems in the world and learned about the hard way, of course, what can happen. So, but again, we're happy that someone else is doing this, and I'm clearly sure it's going to be the way energy is transferred in the future.
Yeah, and I agree in what you say, because I think we have seen, all of us, some applications also in passenger car automotive. I don't really know how much is the penetration in the market, but there is for sure some applications already available.
Maybe I can give one more idea about this, and it's very futuristic. But this technology is bidirectional, meaning you can actually use and develop a system that is able to send energy and to also give energy away. Just imagine in the future, there's swarm intelligence in e-mobility. Everybody's driving e-cars, however, what kind of battery it's going to be powered. But swarm intelligence means that the cars are talking to each other. That means the whole way of driving will change. So people will not drive, the cars will drive themselves, meaning also they will really drive close by close to each other because they know exactly when the car in front of them will start driving. So it's more like a snake than like a large or like a worm which goes through the streets and will fully be automatic. And now imagine you have the opportunity to exchange energy from the first car in the row to the fifth car through the line of cars. Just imagine this kind of technology, what would be possible, which would not be possible with contacts. And that's going to give a huge opportunity in the future. How are we going to power cars? How are we going to optimize energy flows? How are we going to store energy? And how are we going to transmit energy? And we really believe wireless has the lowest threshold of getting energy to somewhere. And this means in the future, we might need much smaller energy capacitors, much smaller batteries, because it will be very easy to get energy from A to B. And it's not so much about who has the biggest battery and can store much. Just imagine you really can use the whole line of energy in the cars to optimize it smartly, calculating it, and all those things. So it's very futuristic, but that's a technology that might come, hopefully still in my age and our age, Mirko.
Yeah, absolutely. Yeah, very futuristic. I agree with you, but maybe one day is coming. Okay, so at the moment we don't have any other questions in the chat. I know that we had some technical issues in the beginning of our presentation, but don't worry, because the content is being recorded, so we will share the link and you can watch completely on demand when you get the link.
And most, if you have personal questions about technology, about the potential or whatever, or just in general want to chat, please reach out over LinkedIn. There's, I think, 2 persons with the same name, Julian Seume. I'm really happy to connect with all of you. I really like this industry and what's possible and what's happening. And once again, Tsapi and the whole team who managed and organized the show, very great event. Thank you so much for having us. Hopefully, yeah, you're going to have a lot of attraction and many good discussions. Let's share knowledge and ideas in the industry. I think that's most important. Thanks again. And yeah, Mirko, see you soon, hopefully, on the next show.
Okay. Bye, Julian. Thank you for your time.
Thank you.
Yeah.
Bye-bye.
Bye.
Bye, everyone.